hopefully you can.
Okay,
And
let me try. I also sent the link in the chat, so
okay,
hopefully you can all see it.
cool.
Yes?
It's good.
Okay. So I'm going to briefly go through some of the slides, then I will give some live demos, how to utilize that. So the slides have some links. Feel free to check out the links after the meeting. And first, I'm going to briefly introduce the GitHub organization, Open Geospatial Solutions. So this is the GitHub organization I created to host some of my open source packages. Not some, like all of them nowadays. So I started doing the software development in 2020, right after the pandemic. The first one I created that was widely used is the GMap, and 2 years ago it has been adopted by the Google Sensing team, and now the Google Sensing team has been maintaining the package. More recently, I've been working a lot more on GeoAI and also segment geospatial. So for today, we're going to cover just the GeoAI package. But besides Python, I also have some other QGIS plugin, MapLibre GL plugin, and some of the data catalog. You're welcome to try out. So today, we're just going to cover one QGIS plugin specifically, and it's called GeoAI. It's just a package name, okay? I'm not claiming like GeoAI is mine. It's just like nobody is taking the GeoAI name as the plugin or the package. So I kind of the goal is to make it accessible that anyone, even without technical skills, they can also use the plugin to do some AI stuff on geospatial data. It's open source on GitHub, and welcome your contribution if you want to contribute some of the source code, example, to the repo. You feel free to submit feature requests or GitHub issues. And initially, it was developed as a Python package, so you can install using pip and conda. Of course, you need to have some GPU support if you want to utilize that. But it also runs on CPU and also Mac OS if you want to, but it's a little bit slower. So the recommended way is to have some NVIDIA GPU to be able to utilize some of the stuff. But if you don't have any, you can also try Google Colab. It's free, so you can also use some of the examples to run on the Jupyter notebook within Google Colab. So for today, I'm just going to focus on the QGIS plugin. It's available on the opengeoai.org website. And so I have a page dedicated to the QGIS plugin, showing you how to install the package and also some of the key functionalities, also some of the sample data. So everything is reproducible. What I'm going to present today, I'm going to show you the live demo so you can get the same result. And it's a little bit tricky to install the QGIS plugin, but I've made it a lot easier. So hopefully, just one click and then you'll be able to detect your GPU and then install all the dependencies. But if you run into any issues, feel free to post issues on GitHub. It's a little bit difficult, like to cover all the scenarios. Some users might still run into issues, but it's kind of the issue with the PyTorch and some of the GPU drivers related stuff. The package itself is actually not that heavy, but some of the GPU dependencies can be tricky to install on some operating system. Again, if you run into issues, reach out to me on GitHub. And I think I published the QGIS plugin a couple months ago. It's available in the official QGIS plugin repository. So all you need to do is just to search the GeoAI in the plugin manager. And then once you install, when you click any buttons trying to open the plugin, it will show you this kind of a one-step installer. So you can just click install dependencies, and then you will be able to install all of them. So this was inspired by another AI segmentation plugin developed by Terranet, and I kind of brought the idea, so it also makes it easy for you to install the dependency. In that way, you can use your existing QGIS installation without having to create a PIPC or Conda environment to utilize that. And it makes it a whole lot easier. It also works across platforms. So under the hood, it's going to create a QGIS plugin kind of a directory under your user directory, and then install all the dependencies. So it's separated from the original QGIS like Python environment. So in that way, it doesn't break your QGIS Python environment. And I'm hoping that QGIS like in the future can make it easier to create some virtual environment without here is the plugin developer having to hack But right now it's separate environment, and sometimes it also causes issues because of NumPy, pandas. Some of the dependencies kind of a little bit tricky. But I think most of the issue have been fixed. So hopefully it will be relatively smooth to use the QGIS plugin. So just install, then you will be ready to go. So here is the interface. So far, I think I have 7 buttons here that allows you to do segmentation, and then using some of the visual language model and also segment anything. I will show you in the live demos later. Also, there's a button for you to clear the GPU if needed. And another thing I want to point out is that you can also install the latest version of the plugin by checking the updates, because sometimes I update this one pretty frequently. It might take some time to appear in the official QGIS plugin repository. So if you want to get the latest version, you can install from GitHub directly by checking the updates from the menu. And here, just show you the demo. It's pretty easy. This demo actually was a couple months ago. It doesn't have all the buttons, but the functionality are pretty much similar. So you can use visual language model. For example, here you can query any satellite imagery. For example, how many buildings in the image, and then you just run, you will get the result. So under the hood, it was able to use, for example, the Moondream language model with visual language model to query. You can also do object detection. So everything I'm showing you here is on the fly. So it's not speeding up at all, and it's pretty quick. As long as you use some GPU on your computer, it should be pretty quick. Another one is the segment geospatial. So this is also quite popular functionality that allows you to do image segmentation or instant segmentation from the imagery, but just by using text prompt, or you can just do a bounding box, and then you will be able to find all the similar objects within the imagery. So in this case, it can be building, it can be trees, it can be anything, and then you can save the result as GeoTIFF or as vector data pretty easily, and then you can use that to filter out some of the false positive if needed. Another functionalities allow you to train custom deep learning models. So for example, I wanted to train a building detection model. I have aerial imagery, I have the building footprint. Then you can create the image chips, and then you can select all kind of architecture. And then just with a couple click, you'll be able to train your own object detection models. Then you can apply to your new imagery to do inference. So for example, here I have another imagery beneath. Then I can use the train model. Then you can just run inference and get result pretty quickly. So this can be done in just a couple of minutes, and the result is shown beneath there. You can also vectorize the buildings, regularize the building if needed. So everything is pretty straightforward and easy to use. It's not going to be perfect. Nothing is going to be perfect with AI, but at least it gives some initial results that you can use to fine tune the results if needed. So this is for the SamGeo. Another integration was the Deep Forest Python package. So allows you to specifically do tree detection from any imagery. So it has been trained on a lot of images. You just like select the pre-trained model, and then just input any imagery. After that, you can save the result as either vector or raster data. And lastly, you can also do water segmentation. So this is sensor agnostic. So that means you can input any satellite imagery, aerial imagery, as long as it has 4 spectral bands, RGB and also near infrared. Oh, by the way, so this one is based on Omni Watermark Python package by integrating to the plugin so that there's no coding. All you need is just select the imagery, then you can save the result. So the workflow is pretty much similar for all the plugins. All you need is just like think about what do you want, and then the plugin can quickly get the result. Then you can fine tune the result. So in this case, I apply on the USDA name imagery 1 meter resolution, and it was able to detect wetlands and also waters from the imagery by simply select. For example, here I can just select one water body, and then I can just do the segmentation. You will be able to extract all the water bodies. So basically use that one as the example, as a reference. You will find all the similar objects. And you want to see some false positive, that's normal because the segment NC model is not trained on satellite data. I certainly got some of the object going to be confused with the water body, but you can do some filtering or do some post-processing after you get the result. It's still much faster than you trying to train a model yourself. And so this kind of the demo. I will show you the live demo later. But if you're interested in learning more, I also publish a short paper describing the GeoAI package. If you have journal publications, you are welcome to cite the paper. And I think last month I also published a book introducing a lot of functionalities for the GeoAI Python package, not just for the QGIS plugin. And you can find it on Amazon and also PDF on LinkPub. But all the source code are freely available on the book website. You're welcome to check out the link, and you'll be able to reproduce everything that I show in the note in the book. So all the code examples end to end, from getting the data, processing the data, train the model, run the inference, and also doing the validation or accuracy assessment from the data. And you can just download the notebook. You can run on your computer, or you can run it on Google Colab. And if you're new to programming, you want to learn more, I also have some other books introducing, for example, basic GIS programming, or to do like scalable geospatial analytics with DuckDB, and also the last one, the GeoAI books. Again, all the source code are freely available on the website. Check it out. But you can also buy all of it together at a discounted price. But you don't have to. You just download the notebook, and then the PDF and the hard copy basically contains the text and also figures, images, so it's more comprehensive. But if you already have program background, you probably just need the Python, and then you can just run through. Then you can make some customization on the source code to apply on your old data. Besides the books, I also have a YouTube channel that I publish videos regularly. Try to do that every week. But sometimes if I'm too busy, you might not have video in a week or two. But definitely at least once or twice a month, I'm trying to. And specific for the GeoAI, I have published 47 videos, 19 hours. So you can sleep 5 hours and you can spend all the time watching a video in one day. So all the key functionalities that the GeoAI package has, you can learn from there. And also every video has a Jupyter notebook that you can replicate. So if you're someone that really want to dive into GeoAI in a practical way, then you can check out the video tutorial series. Okay, so that's what I want to show you. I think only maybe 15-20 minutes. So next, I'm going to show you some live demo, see how it works. All the sample data can be downloaded from source co-op. So you can click the link. It should take you to the website here. Then you can just click the download button to download this one to your computer. Then you can follow through the demo, or you can try it out later on your local computer. You can also see inside what's available here. I'm going to show you basically all the functionality available in the QGIS plugin with all the sample data, so that you can replicate, and then later you can try it with your old data. But like I said, it's not going to be perfect. You might run into issues. It's normal. Just post some issues on GitHub, and I can try to fix the bugs if needed. And lastly, you're welcome to connect with me on social media. And I post updates pretty regularly. Before I get into that, any questions so far? Yes.
Yeah, I was wondering. You got everything using. Sorry, you looks like you're using CUDA for everything. Do you have the option for the AMD users to convert to OpenCL or?
Good question. Right now, it's not. It all depends on PyTorch. Whatever PyTorch support, we can support it. So if PyTorch support AMD, I don't have an AMD like replica to test it, but it's all inherited from basically the PyTorch CPU. Whatever it supports, then we can do that. If it is not, then I can look into that to see how to enable the support.
Okay.
Because on my computer, I mostly just use CUDA GPU and also Linux. And I think initially when I developed the QGIS plugin, the most challenging part was to test it on different operating systems, Mac, Windows. It took me a while because in the installation at the beginning was actually quite challenging. But after I switched to the one-click installation, it seems works much better now, but I don't know. I need to try more. So if you have a specific AMD, if something doesn't work, please post an issue on GitHub. I can look into that.
Okay, thank you.
Of course.
I just had first of all, thank you for trying to make the installation of the dependencies as easy as possible. I really appreciate that. But I just wanted, with the update from within the plugin, does that update the plugin as well as those dependencies?
Yes and no. Yeah, yes means you update the QGIS plugin. So next time when you launch the QGIS plugin, if some dependency, it will update basically the dependency list. So if you open QGIS again, if it doesn't detect the dependency, it will ask you to one-click install again, but you only install the new dependencies.
Okay, great, thanks.
Any other questions? If not, let's get into the demo. So I'm going to show you how to use that. I'm using a remote desktop, so the image quality might not be ideal, but it's going to be faster because I have a better GPU on the remote computer. And so I would recommend is to, if you go to the opengeoai.org website, and then click the QGIS plugin here. Let me see if I can send the link here in the chat. And so the page here has very detailed instructions showing you from installation. I also have a lot of a video tutorial showing you how to use it, how to install it. You're welcome to try it out, but I think it's pretty easy. Once you install the plugin, it should be pretty straightforward to use it, just using the interface. And if you scroll down to somewhere, maybe on the right here, going to the usage section. So this one shows you the kind of information for each icon or each tool, and also provide the sample data here. You can click to download individual one, but on the slides, I will show you like one, you can download the entire zip file, so you don't have to download them manually. So it contains everything that I put here on this web page. It also has some of the interface in here. So if you need more detailed information about each interface, you can check out some of the information here. I'm going to switch directly to the QGIS interface in here. And if you're already QGIS user, it's pretty straightforward. Just click the plugin manager and then go to all GeoAI and then select that. So from here, you can should be able to just click install. Then you're going to show you the buttons here. Also at the top, there will be the menu. So this is showing you some of the functionality. In the future, when I include more, I mean the buttons, the number of buttons will grow, and also the menu will grow. But hopefully, it's still manageable. There actually are a lot of functionality in the Python package that are not in here. There are a lot more. If I add all of them, probably the menu will go to the bottom here. It could be going to double or triple, but I only put right now the most commonly used functionalities in here. And in the future, there will be more, for example, foundation model, satellite embedding, and other stuff will be also coming up in here. So you can follow the repo to get more updates. And the plugin has these 6 buttons here, and also the one for you to clear the GPU memory, because some of those might be very GPU intensive. So after you're done with some of the tasks, you might want to clear the GPU memory. So I'm going to start with the first one, the tree segmentation. The second one is the water segmentation, and then the visual language model, segment geospatial, semantic segmentation, and also the instance segmentation. I think the last one, the instance segmentation, is the most computational intensive. So I want to start with the easy one, the tree segmentation. I'm going to just find a sample file in the zip file, and specifically for this one, we're going to using this one sample data set from the deep forest package. You're welcome to try our own data, but just be cautious. Sometimes some of the new data, if too big, or some of the data format, it might not always be supported. So what I recommend is always try out the sample data so that it's reproducible. If everything works, then you try your own data. If it doesn't work, there might be some issue with your data, or it might be this issue with the plugin. But at least if the sample data works, that means at least the plugin is functional. So I'm going to click this one, and then on the right here, you will see it's going to pop up this one showing you this is from the deep forest, and you can select the model. Actually, deep forest has 5 models. You can detect trees, birds, livestock, nest detection, and also dead trees. I have tried just the tree detection, but you're welcome to try out other all those models need very high resolution because those are relatively small like objects. So you do need to have like area imagery you're able to build direct. And here you'll be able to switch from CUDA and CPU, but most of the time you can just select auto. You'll be able to detect whether you have GPU or not, and then just click this load model. It's going to download the model from Hugging Face automatically. And after the model is loaded, you will see the green text here saying the model is loaded. Then you can come here to select the input data layer. So I'm going to select this one, and then, or you can refresh it. So that if you edit new data, it doesn't show on the list, then you just refresh it, then you'll be able to see this one. After that, just click set image from layer. So basically just do the encoding on the imagery. After that, you are ready to do like prediction. So from here, depends on how big is the imagery. It can be a single image. That means it's going to process in one round. But if the image is pretty big, you might want to use the tile. So it's basically doing the tiling. And so you're going to subdivide the image into smaller pieces. Then you can do the segmentation. For this sample image, it's pretty small. So I'm just going to use a single image. Then you can set a score threshold. That means for the detection, every object is going to have a threshold. I'm just going to use default one and then just run it and take a look just within a second or two. Then you get the tree detection. Again, it's not going to be perfect, okay? You need to fine tune the parameters, or you need to train your own models if it doesn't work very well. But at least you can see how easy it is. Just one click, then you get the tree detection result. You can open the attribute table here to see some of the result. You can see basically the bounding box, the label, the score. So the score is basically shows you the probability, the confidence score of the detection. So sometimes you might have some false positive. So you might want to filter out, for example, the smaller, the low confidence score. Sometimes those results are not good. Then you can filter them out if needed. And from here, so you can see some of this. It's very tiny, so this is the image quality is not very good, so it might struggle sometimes. So besides exporting as vector data, you can also export as raster. Go to the output tab. So from here, you can also select vector, raster, GeoJSON, Shapefile, or GeoTIFF. So if you click this one and then just click save result, you will be able to save this one as a raster imagery. So from here, now we have this raster imagery. And it's grayscale imagery from 0 to 55. That means each object has a unique ID. So basically, you can export as a raster imagery if you want to do some raster calculator stuff if needed. Another thing I want to mention here is that it also allows you to export the data as training data to some other model. So imagine you use this one, you want to fine tune the model. For example, if the result is not very good, you can do some customization on the inference data. And once you get the perfect data, you can export this one, for example, to Coco or YOLO. That means you can train your own model based on the preliminary output from here. And this is how easy it is to use the deep forest model to do tree detection using the sample data. Okay, so that's the first example. Questions? Am I still connected, or is it too easy?
That's pretty amazing.
You're connected.
You're here.
Okay, now let's move to the second one. Okay, so that's the tree detection. The other one is the surface water detection. So I'm going to use this Sentinel-2 dataset. I'm going to drag it from here. Oh, not this one. This one is the result that I showed earlier. Were any of you able to run like the plugin, like what I'm showing here? If you get any results using the sample data. Let's see here. So I'm going to use this Sentinel-2 imagery. This one is the 6 spectral band imagery. And if you can open this one, you can see it's with the band combination. I'm going to change to 432. So it's the 4th color composite. And then hit OK. And so this one, oops, let me close it. Open the second button here. This one is based on the what's that called? Omni water mass package. And so here, very simple, just refresh, select the imagery that you want. And from here, you can select the sensor. So I'm using the Sentinel-2, have the 6 spectral bands, or you can use Landsat. Or if you have some custom imagery that has near infrared band, you can also customize it, 1, 2, 3, 4, for example. And so in this case, I'm just going to use Sentinel-2. It's blue, green, red, and near infrared, and also the shortwave infrared. And pretty much that's it. Everything else, you can just use the default settings. So for the page size, I think I can read it maybe 500. You can customize it. So it depends on the object that you are interested in. And these are some of the things you can adjust yourself. If you have a smaller GPU, or you might want to reduce the base size. If you have a larger GPU, then you can increase. For example, let me see, I can try base size 8. So under the hood, it's going to subdivide the imagery into smaller pieces and then feed it into the model to run the segmentation. And so here, I also recommend that you turn on the vectorization. So the smooth polygon, you're going to get much better result when if you check this one, because those are like natural water bodies. The boundary is pretty smooth. So if you don't want to get some pixelated boundary, then you check this one on. And after that, just click run segmentation. It depends on the GPU. It might take a couple minutes, and also depends on how big is the imagery. So if you want to check, for example, oops, what is overlap? Oh, page size. Okay. Maybe 2000. Because when you have overlap, the overlap need to be larger or smaller than the page size. So let's try again. Hopefully it works. And because I'm on Linux, so I can actually check if the GPU is being utilized. So under the hood, you can see here, it jumps up and then it should be done. Then the GPU drop back to the close to 0. So just the indication of it's using GPU or not. And take a look. All right, pretty quick, right? Only just a couple seconds. Now we get the water body. It's not perfect, but it's pretty decent. So you can change the color here, the symbology, and maybe change to how about yellow color, so it's more obvious. And it also saved as the raster imagery. And so now let me zoom to here. All right, pretty close, you will see. And this is what I mentioned about the smooth the polygon. So you can see it smooths pretty nicely. Also, you can open the attribute table here. Under the hood, you also calculate all kind of geometry properties. And this can be useful if you're trying to filter out some false positive. If you know the maximum size or something like that, you can see, you can set the minimum size. So for example, this is the smallest one, I mean the object. So I can zoom to here, and then you can smooth out. It does look like water body, and you can also see some of those are missing. Those are basically the pretty common issues. If you have very elongated, very smaller one, you might need to reduce the threshold so that you can also detect those smaller water bodies. And you can also filter by maybe the large objects. So you can, besides the size, you can look at perimeter, area ratio, eccentricity, orientation, elongation. So all the parameters, geometry properties are available directly from here. So if you want to use that to run some like analysis, you can do that as well. And you also have the raster imagery. So just the raster mask, 0 and 1. So if you want to just get the raster imagery, you can do as well. And this is sensor agnostic. So that means you can apply to any imagery as long as it has 4 spectral bands. If you want to zoom in here, that's what I mentioned, right? So if you just seeing the imagery, it's going to, oops, it's too very pixelated. And you see the smooth vector boundary looks much better than just the original boundary. And that's about that. Very simple, just any water segmentation. Let me look at the questions. What is the minimum computer capacity needed to run this GeoAI plugin? You can run on CPU if you don't have a GPU, but it's going to be 10 times slower at least. If this one takes 1 minute, you probably might need 10 minutes, something like that to run. But it's recommended you at least have like 8 gigabyte GPU. If you have 16 gigabyte, that's better. The larger, the better. And but if you don't, you can run it on CPU or on Mac computer using unified memory. But some of the models, they don't. For example, the SAM3 doesn't support like iOS, Mac OS, so you won't be able to run some of those models. But many of the models basically based on PyTorch. Whatever PyTorch supports, then you can utilize that. Okay, so that's about the tree the water segmentation. Once you're done, I would recommend you just click this button to clear the GPU memory. So you're going to basically clear the GPU memory so that you don't run into memory issues. And let me remove this here. So the next one I'm going to show you is the visual language model. So I'm going to use the parking lot sample data here. And you can click this icon here. Then you can select the data layer. Select the model first. So you're going to load the model from Hugging Face. It might take a couple seconds. Again, you can look at the GPU usage here. Once the model is loaded, you're going to see the GPU basically increase. So it's here. And then I can just set the imagery, select this parking lot, load the imagery. After that, you can start asking questions. So there are 4 different modes. Caption basically means it can understand what this imagery is about. Just select captions and then click run. It's going to tell you, for example, what this imagery is about. It's an aerial imagery, blah, blah, blah. So look at the detail. You can also change the length. So if you need like longer version, you can select the long option, and then it's going to give you more information. This can be very helpful if you develop some automatic workflows that you want the model to figure out what it is. And then you can extract the dominant features from the imagery. It can be helpful. So that means you don't need human to always looking at imagery individually. So that's the power of visual language model, is to let them understand the content of the imagery, and then you can do the object extraction. So you can combine this one, for example, with SAM3. For example, here it's going to understand, okay, it has buildings, it has cars, and then you can use SAM3 because it allows you to use text prompt. Then you can extract the text prompt from this visual language model, plugging into the same model. Then you can do the automated extraction without human involved. But it can make mistakes, so you still need to double check the result. So the first one is the caption. The second one is the query. The query means you can ask questions, ask the model about questions about the imagery. For example, how many buildings in this image? Okay, and then just click run. See, like less than 1 second, there are 2 imagery in this, 2 buildings in this imagery. One thing I need to point out is that usually it's very easy to answer like dominant object. It's very big, very obvious. The model performs pretty well. But if I'm being like very tiny, small object, not very obvious, the model will struggle. This is just the limitation of all the computer visual language models. Also, you can do like detect. For example, I want to detect all the buildings. So I can just say building, and then just hit run. You see, very quick. I can also detect, for example, trees, and I can select here, maybe change the color to green, and then okay, and then run again. Okay, now I have all the trees, all the bounding boxes. So this is pretty nice if you just want to get some quick counting on the imagery. And the last one is the point. So if you just want the centroid, it can do that as well. So I can detect all the tree centroid, click this one, then you get all the tree centroids. Interestingly, sometimes it means some of the trees here in the bounding box. This basically is just the model. Sometimes it's not always the same for different tasks, but you get basically most of those. This can also be very helpful if you want to get, for example, the detailed segmentation. You can use this one as the preliminary result to input into the segment anything model. Then you can get perfect tree segmentation. If the segment anything model itself doesn't give you a good result, then you can give this one as the guidance to run the inference on any data that you want. Okay, so this is about the visual language model. Then again, you need to clear the output here, the memory. Now we can move into the next one. I'm going to use the segment anything model. So for this one, I'm going to select which data set. I'm going to use this UC Berkeley imagery. And here, I can use the SAM3. So SAM3 has 2 backends, Meta and also Transformer. You can just use the default one, then just click load model. And this model, I think, is like almost 4 gigabytes. So you do need a decent size of GPU. Otherwise, it's going to be not enough to load the GPU. So you can see here, it jumps up. I have I have two 48GB GPU, so it should be sufficient to run pretty much any models in here. Once you load the model, then you can set the imagery. Again, you can refresh the button here and then select the imagery, and it's loaded this imagery into the model. It can also do any other imagery. So if there's no RGB, you can also customize your RGB combinations from here. Then they start doing some segmentation. So SAM3 has some text prompt functionality. So that means you can ask using free-form text. For example, I want to segment building, just type building and then segment text. So this one, okay, it's coming up. Just take a couple seconds. So I just type text and then you will segment, just give you the building and pretty decent. You can zoom in a little bit, zoom out a little bit, and you can change the symbology here to see the result. Pretty close. Of course, there are going to be some false positive or some omission errors. It's pretty normal. The SAM3 model is not trained on satellite data, but trained for learning capability is pretty amazing. So you can get this pretty easily. If you want the raster data, you can go to the output tab and then click raster, GeoTIFF, and then save mask. It should be able to give you the raster mask as well. So this one is a grayscale imagery, 0 to whatever number of object that you have. So it's pretty simple here. Like you can turn the layer on and off if needed, or if you want, you can combine this one with some other plugin to do like comparison before the imagery and also the result. So this is the text prompt functionality. The other thing I want to mention here is the interactive. So this one is also very powerful. Sometimes, for example, the text prompt doesn't give you any good results. Then you can use this one to give the model some guidance. For example, here I can draw the bounding box. So I just click the draw box and I say, okay, this is the example I want to extract. So you draw a bounding box around this object, then just click segment by box and see how quick it is. It's going to use this bounding box, this object, domino object within the bounding box, and then you detect all of them. So essentially what we're trying to do here is that to extract all the buildings from this imagery, and it does that pretty nicely. Let me change it to the vector geo package so you get a little bit better results. Oops. Right, so let me turn this one off, and then you can see here it's very much similar to our text prompt, but it's particularly useful if you are dealing with some object that the text prompt doesn't really recognize, or it's something hard to describe. Then you just, okay, this is the object I want, find off then. Pretty cool. Besides that, or like building is quite obvious, maybe it's not as good as you want. We can also try something else. For example, here, let me zoom into, let's say, okay, I want to detect something like trees. Then I can do the same thing here. Segment, draw the bounding box. And sometimes it's not perfect. I mean, I'm doing live demo. All kinds of things can happen. You might get good results, but that's pretty normal. Let's see how it goes. So I'm trying to detect all the trees. Okay. So it does mean like it detects some of the trees and the grass. This one is not very good. That means it's kind of very similar. Sometimes the model may struggle. So you do need to basically play with it, and then select some very typical object. Then you can start getting some good results. So this is how you can use SAM GeoS3 to do the segmentation. So this is the bounding box, but you can also do point. For example, here I can select segment by point, so I can add the foreground, the background. Foreground means it's the object that I want. So I can select here foreground, and then just select this one here, and then I can just say segment by points, and let's see how it goes. Okay, you see, you can detect the building, so it's pretty intelligent. It knows, like, it's trying to guess. Actually, the model can output 3 masks. You're going to pick up the one with the highest probability. So in this case, it was able to detect the buildings by just providing 1 point. So imagine if you need to do some digitization of your data, placing a point is going so much faster than you just trying to simply to manually digitize yourself. So this is something that you might want to try. You can also do like batch segmentation. So if you have some data, you have a lot of points, then you want to do the segmentation easily, you can do that as well. Maybe let me show you another example, because this is not, I don't have the training data, but let me create the output and then show you another example to use this so-called the base segmentation that might be very useful. So let me clear all this. I'm going to load another data set here. I think it's the Washington State building data here. So imagine that you might have some data from other deep learning models. So in this case, I have some buildings from other imagery. And if I zoom in to show you here, right, I have the bounding box, but the bounding box are not perfect. It doesn't really give you the nice segmentation of the buildings. But if you already have this from some other data output, then we can use this same tree to actually to do the segmentation. So let me show you here. I'm going to go back to the first step to load the model again because I cleared the GPU. All the data, all the model has been clear. And then I can just click this one, set the imagery. And then I can come back here to do the base segmentation. So for this case, I can select refresh, and then I can select, for example, I can use the same choice as the input. So basically all the points. Okay, the color is not very good. Let me change the color here to white color. Oh, it's too big, sorry. Size, and maybe let's say 2. Okay, so now I have all these points, the center of the buildings. You can just select this one, and then you can run base segmentation. Oops. Interesting. It was working before. Probably it's just some of the package dependent issues. I won't be able to show you here. I need to look into that. Yeah, I'm pretty sure just the project, the package, like the conflict with the QGIS and the conda environment. Anyway, I'll fix it and update the plugin later. And so this is about the base segmentation mode. There are two more here. So if none of those works for you, then you can train your own segmentation model. So let me show you quickly. We only have 5 minutes, but I want to try as best I can to show you some of the functionality. For example, I want to train a building detection model. I want to use the USDA net imagery. So let me drag the data here. And for example, oops, I think I have some existing data here. Let me drag this. Oh, no. So I have some building data. And I also have the testing imagery, but I need to switch don't use the transparency so it doesn't look weird. Okay. And so I have these 2 data set. Then if you really want to do some like detection, train your own model, you can do this one pretty easily. So create a training data. You can select the imagery that you want, and then the building, the vector data. After that, it's pretty simple. You don't need to, you can adjust some parameters, but you can just say, I want to save the tiles somewhere here. And you can create a new folder, say tiles. Then just click set the output, and then just export the tiles. It's going to basically subdivide to convert the vector to raster, and then to create the image chip for you. It might take a couple seconds, minutes, depends on how big is the data set. So essentially, it's going to create a training data needed for the model. So here you will see the tiles. Inside you will find the images, the small tiles, and also the corresponding image labels. So the vector data has been converted to raster. After that, then you can automatically, you want to select the directory. From here, you can change whatever model you like. So these are all the model architecture available from the PyTorch segmentation models. And then you can select the encoder and everything. Also, you can select, for example, how many channels. If you have like 4 or 6, you can customize it from here. And after that, then you can start doing the training. It's going to take some time, depends on your GPU, but you can monitor the progress. You can also look at the GPU. It's going to basically spike. And then you see here, it's training. Take a couple epochs. So hopefully it'll be done. Then you can run the inference. Here, after it's done, we're going to switch to the inference tab. Then you can run inference on other data set. Anyway, I'm running out of time, so I'm going to stop here. But you can try out the last one, instance segmentation yourself, if you want to. But if you run into any issues, feel free to let me know. Thank you very much.
Cool. So does anybody have any questions? I feel inadequate at this point because I need to learn more on AI, but that was cool.
It's pretty easy, right? So here it's done, and then now I can switch to here quickly show you the inference. So I'm going to use the raster test here, and then everything is pretty much automated. Then you can say run inference. Then you should be able to get the building detection result. So this is so much easier end to end. You don't need to write any line of code. You better get the result, and then it's going to show you the output pretty easily. Oops, output saved too. Okay, might be a bug. It should come up here, but I haven't used it for a while, so I need to maybe debug it. Anyway, that's all I have.
Cool. I saw GS Chatham somewhere. David, is that you? I saw people raising their hands and then the hands disappeared. Sorry. But speak up if you have a question. Well, maybe not. So, oh, okay, good. Doug, go for it.
I noticed you were doing areas with just one image, and I'm sure that's for brevity of time. How well does it scale when you do a VRT of multiple images, of hundreds of images? Do you need larger video card, or does it just?
Not necessarily, because even you have more images, it's still going to subdivide into smaller. So the one controls the amount of GPU is your base size. So if you have smaller GPU, you can do. I don't have all the functionality, but you can check out the website. It also support like doing base segmentation, or when you are creating a training data, there are different ways you can do, right? So for the image chips, you can do not image chips, image tidying, probably, or maybe create vector data. I think it's create training data. So this one shows you different methods: single imagery, single vector, multiple imagery, single vector, or multiple imagery, multiple vector. Is all supported. And you can also look at the book here. The book also has examples showing you when to create a training data. You can have different ways. So all the source code are available from here if you want to try it out. Not everything is available in the QGIS plugin, but you can do that programmatically using the package as well.
Thank you.
Guy has a question.
Yes, I have a question. I don't know if you understand my English. Sorry for the mistake if I
No worry, I'm not a native English speaker as well. My face is very sick, so I don't care if I'm really authentic or not, as long as people understand what we're talking about.
So my question is, I saw that he used this plugin on small size of picture of small size. I want to know if it can work on a large scales, for example, a Sentinels 2 imagery of large scale.
Yes, it can. It all depends on how big is the GPU. So under the hood, when it's training the model, it's using the image pairs, so it doesn't really require a large amount of GPU. When you are running the inference under the hood, you also set basically the image, the type size, and also the overlap. So it's doing basically base by base. So it should not like require a large amount of GPU. You should be able to run it with original. For example, I've run it on a couple gigabyte the USDN imagery, or you can also run it on the entire Sentinel-2 scene as well.
Okay, thank you.
But if you only have a small 4 gigabyte GPU, then it's going to be tricky. It depends on how big is the model size. For example, for SAM3 is like 3 or 4 gigabyte, then you need at least maybe 2 to 3 times, because you need to load the model into the memory and then also need to run the inference. But if you're training your own model, you don't really need a large GPU, because the model size usually is a little bit smaller.
Cool.
And there's another one from Thomas. Assume you are using segmentation to identify disturbance in. Go ahead.
Yeah, it looks like Israel raised a hand.
Yes, I have my hands raised. Thank you so much for the privilege to ask my question. We sent my earlier question while you were answering the last person who asked the question, you answered. And then I had a second question, so I'm going to quickly ask that question. Have you considered the possibility of maybe letting all these things that requires GPU run on the cloud? And I'm just asking, I'm just thinking aloud. Will it be possible to have some of these things run in the cloud so that those of us who have only access to smaller GPUs can still be able to use some of these things?
Yeah, in the cloud, you just use the package. So you can install anywhere that you can run Python and also have access to GPU. It certainly can. And actually, the package also has REST API. So you don't necessarily have to run everything locally. If you really want to try it out, there's also, if you go to the original package, there's a oh, not this one. It's the same the same Geo. So it has the API, so you can run it as a REST API. So you can send the images to the API endpoint, run the result, and then get it back. So it depends on how you want to do that. But in the cloud, probably you don't really have access to the QGIS plugin because you need the interface. Unless your cloud environment has QGIS installed, that you can use the interface. But you have the Python to do it programmatically. It certainly should be feasible. Just like any other Python package, you can run it in the cloud as long as you have those environments set up properly.
Cool. Anybody else? Any other excitement? Well, hey, that looks like it's it, I guess. Man, thank you so much for. Oh, somebody say something? Are we good? Okay. Man, thank you, Dr. Wu. Thank you for coming to talk. This was good. Hey, so next month, if everything works out, Lutra Consulting will be here to talk about LiDAR. Oh, yeah. So we're going to discuss LiDAR, 3D editing, 3D stuff, everything 3D. If you know of anyone who's using QGIS in like a local government or, type setup, tell them to give me a shout. We would like to hear from them. I get a lot of local government questions, on using QGIS. And even at a meeting this previous week in Tennessee, I got a lot of questions from, local smaller county and city government. So I'm going to try to track down some people to do more discussions on that also. So awesome. Well, presentation number 2 is in the books.
Thank you very much. Yeah, feel free to reach out me on social media or on GitHub if you run into any issues or if there's any feature request. I will try to find time to implement more features so that you can cover a lot more use cases. Again, it's free, open source, so you can also customize it or use it in commercial applications. Okay, thank you, everyone. See you next time.